Hello, my name is Nathan Mettens, and this is my final project for Intro to Computer Security. For this final project, I tackled 3 TryHackMe rooms, and I'm going to go through each of them individually. The first one is called Capture. Can you bypass the login form? So this was an easy difficulty, but although it was easy, it still took me a couple days and numerous hours to complete. This is the home page, and the first thing it asks you to do is download 2 text files, and those text files are passwords.txt and usernames.txt. So here's the head of both. The first one contains usernames and the other one contains passwords. And there are 877 total usernames and 1,500 passwords. So once I got to the website, this is what it looks like, intranet login. And the idea is to enumerate the usernames, and then once you get a valid username, you enumerate the passwords. And this is a brute force attack on this login form. And once I typed in my name and the usernames and then a random password, I got an error that says the user does not exist. So this was a big clue that once I try to log in with the correct username, the message might be different, such as incorrect password or invalid password. So that's the first idea. And then I tried 10 more times, and on the 10th try, a CAPTCHA popped up. So this was kind of difficult to parse out because you have to solve the CAPTCHA before you can log in again. And then these are my basic curl commands that I used for testing. So just curling the URL, and then I would curl the URL with the D flag in order to pass data, such as username and password. And then this is the curl return from the GET request. You can see here that there's data and too many login attempts, the CAPTCHA, and then invalid CAPTCHA. So if you get the CAPTCHA incorrect, you're not going to be able to attempt the login to see if the user exists or not. But once you solve the CAPTCHA properly, then it'll tell you if the user exists. So I created a script that took many, many attempts. And what it does is it loops through the usernames here. And each username, it curls the web server, and it uses a username and then a random password. And then it checks if the CAPTCHA is enabled, and if it is, it parses out the CAPTCHA. And then it's the mathematical equation here using grep. And then once you get that mathematical equation, you can solve it using this with the CAPTCHA expression. And then once you solve it, you can post again, and this time you pass the username, password, and the CAPTCHA results appended at the end. And this will tell whether or not the user exists. And then once you do all of that, you check if you get user does not exist, or if you get invalid password. So once I tried this, it looped for about 5 or 10 minutes. And once I got to the 307th username, it said that it was a valid username, which is great. So once I got a valid username here in curl, I did the same exact thing, different script, but same process with the passwords.txt file. So I always had the same username, which was Natalie. And then I always tested a different password, checked for the CAPTCHA here, solved it, passed it in again with a different curl. And then once I got no invalid password return from the curl, I knew that the user was correct. So this ran for a while as well, and then I got to the 344th password, and it was skateboard with an 8. Once I got that, I logged in, and I successfully discovered the flag. So this TryHackMe room was very fun, but it took a long time, a couple days worth of work and many hours. And it was a lot of using bash scripting and basic curl commands. And this, the idea of this room was enumeration. So in order to crack login form by bypassing passwords with brute force. And this reminded me of one of the labs we did in the class with using the rock file in order to crack passwords as well. In our second TryHackMe room, I tackled security footage, which is a medium, but it did not take 45 minutes. This one is perform digital forensics on a network capture to recover footage from a camera. So the first thing it asks you to do is download this task file, which is basically a packet capture file with a bunch of packets. So once I had this downloaded, I drag and dropped it here into my desktop. And once you click on it, it opens the packet capture in Wireshark, which I am used to using because I'm in the network security class with Kevin. And then the first thing I noticed here was a green HTTP packet from the source and destination at a GET request. And then I scrolled down and saw a bunch of TCP packets. And then the last one is a red packet, but I decided to go with my gut and investigate this one. So after a lot of trial and error, I followed it with the TCP stream. Once I got to here, I saw that the GET request was a 200 OK response, and all this packet has is a bunch of images. So there's one image here, and then if you scroll down, there's going to be another image here, and this file basically has tons and tons of images. So in order to extract it, I changed it to RAW format like this, and then I saved it to my desktop. I searched up how to investigate this RAW file because there's no really easy way to open it, and I found this foremost command, and if we man foremost, we can see that it recovers files using their headers, footers, and data structures. So basically the raw file has a bunch of files within it, and they're all JPG. So in order to extract it, we can use a couple flags. The I flag, which is the file used as the input file, and then basically we just run foremost I, and then the file, which is images. And once we do that, it creates an output here, and we can go investigate the output. So cd output, and then we see this JPG right here. We can cd into that, and then ls, and we see a bunch of JPG images. So there was about 11,000 JPG images inside of this raw packet. And we can open this output file on the desktop, and we see that here it looks to be a flag that is called FEH. So if I do man FEH, we can see that it's an image viewer, and there's a special flag that's called, slideshow. So you have the slideshow delay, and then you put a number after this option, and that's how fast each picture is going to slide through. So if we run it with slideshow delay, FEH slideshow delay, and then we do a small number like this, we will be able to successfully see each picture loop through like a movie. So then we do the star JPG files, and then boom, we can see what the flag is. The flag, and pasted it into the TryHackMe. And there we go, successfully completed the room. For my final TryHackMe room, I decided to conquer crypto failure. Basically, it's encrypting your own military-grade encryption is usually not the best idea. Although this was a medium difficulty, this one was definitely the hardest one by far. It took me about 5 days to complete, with about 2 to 3 hours of work per day. And on the last couple days, right now, I've been working on it for the past 4 hours to complete this documentation. But anyways, here's the main page, and once you visit the URL down here, the IP address, you see that you're logged in as guest, and then it says that there is cookies and crypt, and these two hints are very helpful. Crypt is a PHP function that has a salt and a string, and then it hashes the string using the salt. So I'm going to explain that further later, but the first thing that I did was inspect the network and then reload the page, and then I saw the cookie, and the user was confirmed to be guest. And then I looked at the HTML, and I found this useful comment here that was hinting that there are backup files at this URL. So I found this function called FFUF, which is a fast web fuzzer that searches for files using a word list at a certain URL. So the word list I used was common.txt, and this is my FFUF command here using / fuzz, which will be replaced by every single word inside of the common.txt file. And after searching, it found these 4 files at the URL, and the most important one is index.php. If we curl with index.php.back, we get this, and we see how the cookie is generated. Has a user agent, and then the encrypted key, all separated by colons. And then it also shows how the salt is created. It's a random salt, and it takes the string, the secure cookie string, uses the salt to encrypt it, and then every single 8-byte blocks is how the encryption is created. And then you can see that if the user is admin, then you get a flag. So how I did that was first URL decode the cookie, because there's %2fs in there, which is a /. And then I looked at for patterns, and then I found that the salt in this one would be rx, because the beginning of each 13-byte block is rx. Another cookie has a salt of K4. And then I tried just manually changing the user to admin in the web browser, but that didn't work. What I needed to do was here, I curled with a -c for cookie.txt to save the cookie inside of this txt file. We can see the user agent is curl, and then the user is, of course, guest. Then I used the php crypt command here to change the guest to admin. So the first 8 bytes of every single block is what you use the salt to hash it to, and it creates a 13-byte block here, which is the first hash for that block. So I replaced the guest hashed block with the admin hashed block, and then inside of the cookie.txt file. And then I curled again the same URL with -b this time, passing in that cookie.txt file that was updated with the admin. And then boom, I was able to get the first flag. So next, we are supposed to find the key. So once we can log in as admin, we know that we have control over the user agent, in this case is curl. We can change that to whatever we want, and we have access to the user. So we have user, user agent, secret key. Now it's time to find the secret key. Here is the script I used, with the help of AI, of course, because I got stuck for many, many hours and multiple days. So once I figured out and understood what I needed to do, it was way easier to code. And then the best thing to explain here is an example. So let's just say, this is how the program works. Let's just say that we have this flag right here, okay? We have this string with guest, and then the user agent, which we can make all A's so that we know exactly what it is, and we can lengthen it and shorten it as much as we want. Let's say the secret key is TryHackMe and then key 1. We generate a random salt, well, the program does in PHP or index.php.back. And then once we have that salt, we can use the crypt function to encrypt every single 8-byte block of this string. The first 8 bytes are this, and this is the hash. And then the next 8 bytes are 6 A's, and T. With the salt, we get this. And then the final one is the last 8 bytes, and then we get that. So this is our secure cookie as when we curl. We get our cookie. So in order to decrypt this, we already know what the beginning part is because we have guest and then 2 A's, but we can change the length of the user agent to have the first 6 bytes to be A's and then a colon, and then we can go through a character set, A, B, C, all the characters from lowercase a, uppercase alphabet, and then numbers, and then we can crypt those and then check if they match the next 8 blocks, the next byte block inside of the actual cookie. So in this case, we try A, B, blah, 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 all the way until we get a match with T. So this block here matches the block in the cookie right here, which is perfect. And then we curl again with, we do a different curl, and this time we update the user agent to be 1 shorter. So this time it's going to be 5 A's. And then we found the T, so we add that to the actual key parameter so that we can save it into a file in case we have to hang and then restart the program. And then we test all the other characters again. We test 1 character each time, so we go through the character set each time. And then once we get that H, we match the next block here, as we can see right here on the next curl command. It returns a different salt each time, but let's just pretend that it's 2C. Once we do that, we go through every single character until we finally get all the matches, and then this is the program working by itself. As you can see, the flag is huge, and eventually it would hang, so I'd have to Control-C, and then each time that it hung, it saved the current flag into the recovered.txt, so I didn't have to restart each time. It hung again, so then I updated again, and then ran again. It continued where it left off. Eventually, it found the secret key down here, successfully finish it. So overall, I learned so much in these 3 TryHackMe rooms, but they did take a very, very long time for me to complete. But I'm very happy with the result because, especially this one was a very proud moment for me to finish because I used encryption, I used decryption and hashing, and I figured out exactly how the index.php.back file was working. And it was very fun to learn a lot about curl and how to make different programs work. So a lot of this was just basic bash scripting, which was kind of difficult because I'm not that good at it, but I definitely learned a lot and I really liked these programs.